Good morning, children. So welcome back to the online session of a physics class. So as we know that we are discussing about the lesson motion. So in the last session, I had explained about equations of motion, derivations of equations of motion by using the definitions as well as derivations of deriving those equations by graphical method also, right? So we know that those three equations are the first equation of motion is equal to V is equal to U plus Et. Then second equation is equal to S is equal to Ut plus half At square. Then third equation is V square minus V square is equal to 2AS. So these are the three equations, right? If you send the minus A square to this side, it will become V square is equal to U square plus 2AS. So S is equal to Ut plus half Et square will be the second equation. This is the first equation. This is the third equation of motion. In fact, these three equations are called kinematic equations, right? So we have derived these equations in the last two sessions, right? So in today's session, we are going to use these equations to solve the numerical problems, right? So here the numerical problems is a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find, the first question is speed acquired. Second question is distance traveled. What is the distance traveled? So before that, in the equations we should know the numerator. What is that? What do you mean by V? What do you mean by V? V is final velocity, U is initial velocity, A is acceleration, T is time, then S is distance traveled. So these things you should know that. What this symbol represents, what S represents, what U represents, that you should know that. Okay? So U is initial velocity, V is final velocity, T is time taken, A is acceleration, S is distance traveled. Okay? So the situation is a bus starting from rest. A bus is starting from rest. What is initial velocity? It is starting from rest. What is initial velocity? Initially it is at rest. So initial velocity is 0. Initial velocity is 0. U is equal to 0. We take it as given. U is equal to 0. U is equal to 0. Moves with a uniform acceleration of 0.1 meter per second square. What is 0.1 meter per second square? Uniform acceleration. That is A. A is equal to 0.1 meter per second square. Meter S to the power of minus 2 is meter per second square. Right? So 0.1 seconds meter per second square with acceleration for 2 minutes. What is that 2 minutes? Time taken for 2 minutes. A bus starting from rest moves with the uniform acceleration of 0.1 meter per second square for 2 minutes. For 2 minutes. Okay, that means time taken. Time taken is 2 minutes. So that has to be there in seconds because acceleration unit will be meter per second square. So convert it to seconds. 1 minute is equal to how many seconds? 60 seconds. Right? So 2 minutes is equal to 2 into 60. 2 into 60 will become 120 seconds. Right? This is time taken. Okay. Find the speed acquired. Find the speed acquired. Initially it is going at some velocity. It is initially it is at rest. Right? It is a stationary object. It will be starting from rest. So initial velocity is 0. It will be traveling in a uniform acceleration 0.1 meter per second for 2 minutes. So if it is travels for uniform acceleration for 2 minutes, it attains some velocity, right? It attains some velocity, that is speed acquired. Speed acquired, that is nothing but V. We have to find out that is final velocity. What will be the final velocity? Then distance travel. How much distance is travel? How much distance is travel? That is yes will be question mark. These two we have to find out by using these equations. Okay. So we know that the relation V is equal to U plus AT. If you want to find out V, you should know U, you should know A, you should know T. Observe that in the equation. Observe the situation. You know that U, you know the A, you know the T. So you can easily find out the V. V is nothing but the final velocity or nothing but speed acquired. Right? Okay. From first equation of motion, from first equation of From first equation of motion, v is equal to u plus at. We have this first equation. We will substitute u is equal to 0 plus a is 0.1 acceleration, time is 120 seconds, right? So 0.1 into 120, 0 plus, that is nothing but the value itself. If you add 0 to that, there is no changes. So it is nothing but 0.1 into 120. Okay, 0.1 into 120. Okay, so v is equal to, how to simplify this? How to write 0.1 in terms of fraction? 1 by 10. 1 by 10 is nothing but 0.1, right? 1 by 10 into 120, correct? 0.1 can be written as 1 by 10, 120. We have 120, 130 are written as it is. So 0 in the numerator, 0 in the denominator will get cancelled. What is the remaining? V is equal to 1 into 12, 12. 12 divided by 1 is 12 only. So V is equal to 12. In fact, it is a velocity, right? So it is a speed acquired. In fact, it is meter per second. So this is the velocity. This is the speed acquired, right? Meter per second. Meter per second. 12 meter per second, which is the speed acquired. So the unit is meter per second. We'll find out the distance traveled. We'll find out the distance traveled. Distance traveled from second equation of motion S is equal to root a plus half root a square. So we know that u is equal to 0, t is equal to 120, 0 into 120 plus half a is 0.1 into t square, that means 120 whole square. Okay, 120 whole square. So 0 into 120 is 0 only, plus 1 by 2 will write as this into 0.1 can be written as 1 by 10 into 120 whole square, that is 120 into 120. Correct? So this is 0, 1 by 2 as it is, into half a t square presents half into a into t square. That you know that, right? Nothing in the sense there is a multiplication sign between these three terms. So half into 0.1 can be written as 1 by 10 into 120 whole square can be written as 120 into 120. Now we will simplify this. 0, 0 will get cancelled, right? So what is remaining? 12 here. 1s are 2, 6 are. We will write the remaining now. So S is equal to 1 into 1, 1, 1 into 6, 6, 6 into 120, 6 into 120 divided by denominator, 1 into 1 is 1. Clear? So numerator should multiply, denominator should multiply. 1 into 1 into 1, 1 into 1 is 1, 1 into 6 is 6 into 120. In the denominator after cancellation, 2 1s are so 1, here this 1 is repeating, 1 into 1 is 1. Okay? So this is S is equal to 6 into 120, 120 into 6. So 6 0, 6 12, 6 2s are 12, 6 1s are 6, 6 plus 1 becomes 7. So 720. In fact, this is a meter, right? So a meter per second square, so 720 meter. This is the distance traveled. Distance traveled, the speed acquired. Speed acquired is how much it is? How much the speed required? Speed acquired v is equal to the distance traveled S is equal to 720 meter, and this is u plus 80, right? U is equal to 0, u is 0.1 into 120, that is 12. situation. Okay. So similarly, we will go for the next question. The second question is, a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it brought to the rest. Before it brought to the rest. So you have to read the situation. You need to find out the initial velocity. You need to find out the final velocity if it is given. Then whether time taken or otherwise what quantity acceleration is given, everything you should find out from the situation. So you can observe that in the situation, the train is traveling at a speed of 90 km per hour. Initially it is going at some speed that is 90 km per hour, right? So initial velocity, that we can write initial velocity u is equal to 90 km per hour. So that you should convert into meter per second because acceleration will be there in meter per second square. Therefore, velocity is also to be there in meter per second square only. Okay, we convert this 90 kilometer. Kilometer since it is 1000. If you convert into meter, divided by 1 hour is equal to 3600 seconds. Right? Now it is in meter per second. So 20 in numerator, 20 denominator will cancel it. Okay, so if you cancel it, then what will be remaining? 90 into 10 divided by 36. So if you cancel it by 9, so 9 4s are 36, then 9 10s are, right? So 9 4s are 36, then 9 10s are 90, then again 10 into 10 will become 100 divided by 4. 10 into 10, 100, denominator 4. If you divide it by 4, then 4 ones are 4, 25 are. So this is 25, right? 25 meter per second. So 25 meter per second. Okay. Tens are and fours are. So 100 over 4, 25 second. So not this much. Okay, so we will take as u is equal to 25 meter per second, which is initial velocity. Initially we have given in kilometer per hour. We have converted into meter per second. Okay, it is 25 meter per second. Okay, so 90 into 1000 divided by in terms of convert into hour, it will become 3600. Okay, so the 90 into 20 will get cancelled. So 9 4s are and 11s are 100 divided by 4. So it will become 425 square. Okay, then brakes are applied so as to produce a uniform acceleration of minus 0.5 meter square. So brakes will be applied to bring the vehicle into the rest. To bring the vehicle into the rest. That means it will be brakes are applied. It has to produce a uniform acceleration. Whenever the speed will be changes, there will be change in speed. Then there will be acceleration will exist. So that is A is equal to minus 0.5 meter per second square. Meter per second square. Meter per second square. Okay. Then why it is negative? Negative in the sense we are applying the brake. Speed will be decreasing. If speed will be increasing, then it is positive. In fact, it is not actually, it is a retardation. It is a retardation. Okay, so that is minus 0.5 meter per second square. Then how far the train will go before it brought to the rest? So it is at 90 km per hour. By applying the brake, we will be bringing the vehicle to the rest. Now what is the final velocity? Suppose it is 0. Final velocity will become 0 because we will be bringing the object into rest. So final velocity v is equal to 0. Okay. Then what we need to find out? How far the time will go before it run to the rest. So how far this distance travel? Distance travel will be the question mark. Distance travel will be the question mark. So we will write this, what is given and what we need to find out. We have to find out yes. So what is given? Initial velocity u is equal to 25 meters per second. So we will write that they have given 90 km per hour. So we have to find out this 25 meters per second. Then acceleration a is equal to minus 0.5 meter per second square. Then final velocity v is equal to 0. Then yes, we need to find out. Okay. So which equation we are going to use out of these three equations of motion? So we know that first equation is motion u plus at. Then second equation s is equal to ut plus of at square. Then third equation will be v square is equal to u square plus 2as. Okay. So out of these three equations, which equation we are going to use in order to find out the s? So you need to use the equation out of these three where other quantity should be noun. Okay. If I take first equation, I don't have a s. So by using this equation, I can't able to find out the s. Right? Distance travel I can't able to find out from the first equation of motion because it will not give the relationship between velocity and the distance. We'll go for the second equation. Of course, we have a s. I can find out s. U initial velocity I have. T we don't have a time. Time is not given in the situation. Right? So we don't have a time. If I don't have a time, I can't able to find out. Then I should go for the third equation. V is noun. U is also noun. A is also noun. So if everything is noun, I'll use the third equation where I have s. I can find out the s. Okay. So from third equation of motion, we have v square is equal to u square plus 2as. Okay. So v square, v is equal to 0. We write it 0 square is 0 only. Then u square is 25. So 25 whole square plus 2. A is, otherwise I will do one thing. I will modify the equation first in order to bring it to the s. I will send u square to this side. V square minus u square is equal to 2as. I will keep the s here only. I will send 2a to other side. What will happen? 2 is multiplied if I send to the other side. It will get divided, right? So v square minus u square divided by 2a is equal to s. Or s is equal to v square minus u square divided by 2a. Okay. Then we will substitute v value, which is 0, minus u value is 25 whole square divided by 2. A value is minus 0.5. Minus 0.5. Okay. Then we will find out minus 25 whole square is 25 into 25. You will be getting 625, right? So 5 5s are 25, 5 2s are 10, then 12. Again 2 5s are 10, 2 2s are 4 plus 5. So 5, 2, 6. You will be getting 625 minus 625 in the numerator. Okay, denominator you should is 2 into a. That means you should multiply these two. 2 into 0.5. So plus into minus 2 into 0.5. 0.5 into 2. 0.5 into 2. So 2 5s are 10. 2 0 0 only. Then after how many places I have decimal point from the left side? It is 1. So it is, we didn't place the decimal point. It is nothing but 1. 1.0. That is nothing but 1. Numerator denominator cancel. So what is remaining? 625 meters. So distance travel. How much distance must travel? It must travel 625 meters. Okay. So this is the answer for the second question. Okay. So let us verify the answer. Okay. So remaining third and fourth and fifth, you have to do it in your home. That is the homework for you. Third question, fourth question, fifth question. Still you have 3 questions. All these 3 questions are numerical only. You have to solve by using these 3 equations. You can look at these 2 numerical problems how I have solved. Use the convenient equations and solve remaining 3 numerical problems, which is the homework for you. So next class I will go for uniform circular motion. So then after completing this, I will give the answers for the exercise. Okay. So any doubts in today's class, please get back to me. So we will meet in the next class. Thank you.